First question. 1 mole of SO3 was placed in a liter reaction vessel at a certain temperature. The following equilibrium was established, that 2 molecule of SO3 is in equilibrium with 2 molecule of SO2 and O2. At equilibrium, 0.6 moles of SO2 were formed. The equilibrium constant of the reaction will be. So initially we know there are 1 mole of this and there are 0 moles of this produced. But at equilibrium we know there are 6 moles of SO2 is produced. So SO3 will be 1 minus 0.6, SO2 will be 0.6 and O2 will be 0.3. Why? Because there are 2 moles of SO2. So 1 mole ke liye it is 0.3. Now we know equilibrium constant K is equals to concentration of product upon concentration of reactant. So by looking at the equilibrium reaction, I can write the equilibrium constant as concentration of SO2, the square, because there are 2 moles of SO2, then O2, the whole upon concentration of SO3, the whole square. Now by putting the values of the concentration over here, it comes out to be 0.6 the whole square into 0.3 the whole upon 0.4, 1 minus 0.6 for the concentration of SO3, it is 0.4 the whole square. By solving this, we get 0.675. Hence, the equilibrium constant for the reaction given will be 0.675. Correct answer for this question is option D. Looking towards the next question, for the reaction, carbon monoxide plus hydrogen gives you methanol. True condition is. So we know that when number of reactant mole is greater than number of moles of product, then Kp is less than Kc. So when Nr is number of moles of reactant and Np is number of moles of product. So the true condition is Kp is less than Kc. So the correct answer for this question is option C, that is Kp less than Kc. Option C. Looking towards the next question, that Hi was heated in a closed tube at 440 degrees Celsius till equilibrium is obtained. At this temperature, 22% of Hi was dissociated. The equilibrium constant for this dissociation will be. So now here we know that there are 2 molecules of Hi is in equilibrium with hydrogen and iodine. Initial concentration is 2 moles and 0,0. And at equilibrium, the 22% is dissociated. That is 22 upon 100 into 2 moles. So here it is 0.22 and 0.22. So when we solve this out at equilibrium, it is 2 minus 0.44, which is equals to 1.56. So now when we write the dissociation constant, so K is concentration of H, that is hydrogen, concentration of iodine, that is concentration of products, upon concentration of reactant, the whole square, because there are 2 moles of Hi. Now when we substitute these concentration terms over here, hydrogen we have 0.22, iodine we have 0.22, and Hi we have 1.56 the whole square. When we solve this out, it gives you 0.0199. So the correct answer for this question is option C, that is 0.0199. Looking towards the next question, which of the following is not favorable for SO3 formation? High pressure, high temperature, decreasing SO3 concentration and increasing reactant concentration. So correct answer for this question is option B, that is reaction is exothermic. So high temperature will favor backward reaction. Option B. Looking towards the last question, For the system, 2a plus b gives you c. The expression for equilibrium constant K is given as. So, equilibrium constant K is the ratio of concentration of product upon concentration of reactant. So, it is concentration of C raised to the stoichiometric coefficient, that is 3, the whole upon concentration of A raised to 2, that is square, and concentration of B. So, correct answer for this question is option D, that is C cube upon A square into B. Option D.